Exercise 15 deals with the spinal cord and spinal nerves. The meninges, there are 3 layers of these membranes that cover the brain. You also have the same 3 layers that cover the spinal cord: the dura mater, arachnoid mater, and the pia mater. They're going to be continuous with those cranial meninges. And then the cerebral spinal fluid does fill that subarachnoid space once again. So, excuse me, in this cross section, number 1 of the spinal cord and the vertebrae, as you can see, here's the vertebrae. In the foramen areas where the spinal cord is running, you have this epidural space contains fat. You have the subdural space. The subarachnoid space contains the cerebral spinal fluid. As we'll talk in a little bit, when they need to do a spinal tap, it is right in this area, that subarachnoid space, that they have to insert the needle into this area to obtain the cerebral spinal fluid. You can see here listed the spinal meninges. The most superficial one is the dura mater, arachnoid mater, and then the pia mater, which is going to be connected directly to the spinal cord right in here. This is spinal nerve that is extending out from the spinal cord. It attaches to it. Remember, ganglia is where you have a group of cell bodies in the peripheral nervous system. From this diagram, from this cross-section, as you can see, maybe a little bit easier, that you have the, right here is the central canal. In terms of the layers of the meninges, you have got the pia mater, the arachnoid mater, and then the dura mater. The pia mater has 2 special features that help to attach it to the spinal cord, keep it from sliding around. The filium termini is a thin strand of that pia mater. It's going to extend inferiorly from the termination of the spinal cord. It's going to extend down to the coccyx to attach it. And then you've got ligaments that are lateral extensions along the pia mater that connect the spinal cord throughout the entire length to the dura mater. So it keeps it, the denticulate ligaments keep it from, once again, sliding around. So you got to attach to the spinal cord and then attach to the outer layers. So as you can see here, these ligaments that are attaching here. The spinal cord is going to connect to the medulla oblongata. It begins obviously up here. It's going to pass through the foramen magnum that allows the spinal cord to attach to the brain. So that's how it passes through the skull. And it is going to, the spinal cord extends down to about the L1 to L2 vertebrae, where it's going to form kind of a cone-like structure that's known as the conus medullaris. Now you have spinal nerves that will extend below that, but the spinal cord itself will extend to the L1, L2 vertebrae. So if you do a spinal tap, you're going to go below that so you do not hit the spinal cord. Now the vertebral foramen is that opening, remember, at each of the vertebrae, and so the spinal cord is running through there. The spinal nerves can be divided into 31 different pairs, and so the spinal cord is divided into these different segments. There are 8 cervical, 12 thoracic, 5 lumbar, 5 sacral, and 1 coccygeal. Now each segment is going to give rise to a pair of spinal nerves that will extend from that location. The spinal nerve itself will then pass through the openings between the vertebrae. They pass between that intervertebral foramen so that then they can extend out into the peripheral regions of the body. So this is just showing the location of these. As you can see, the intervertebral foramen where they extend out from there. All of your spinal nerves are mixed nerves, so that means it's containing both sensory and motor nerve fibers. And each spinal nerve is going to be formed. You have a dorsal root and a ventral root, and they're going to combine together to form that spinal nerve. So over here we have a dorsal root, and then we have the ventral root, and this is what we're talking about. They will come together and merge, if you will, and form the spinal nerve here. Now the dorsal root has this enlarged area, so if you look at a cross section, you can easily get your orientation from that. This is the dorsal root ganglion. Remember, it's a group of cell bodies. Also, to help orientate yourself, you have what is known as the ventral medium fissure, and then the dorsal medium sulcus to help orientate yourself as to the proper location or orientation of that spinal cord. The spinal cord, as said, is shorter than the vertebral column itself. It ends between the L1 and L2. The cervical and thoracic spinal nerves are going to travel laterally to exit the vertebral column, but the lumbar, sacral, and coccygeal nerves, they're going to have to travel inferiorly down through the vertebral column to reach where they then need to exit via the intervertebral foramen. So they're going to move down and then out. Collectively, all of these inferior spinal nerves are known as the cauda equina. And so this is what we're referring to right here, that these nerves will just move out directly versus here these must move down and then out. And so this is what you call the cauda equina. Plexus just refers to a network of nerves. There's 4 major spinal cord nerve plexus: cervical plexus, brachial plexus, lumbar plexus, and sacral plexus. They're named by the location of where they are at. Some of the major spinal nerves, such as like the phrenic nerve we'll mention, that's going to be supplying both sensory and motor, so it's a mixed nerve. It is innervating. When we say innervating, we mean that it's the nerve that is coming down and stimulating the diaphragm. So it's going to be extremely important in helping with breathing. As you move through the axillary nerve, think of the regions of where you're looking at. This is going to be around the armpit, around the shoulder area. The radial nerve is going to be innervating your extensor muscles of the arm, etc. The ulnar nerve, the median nerve. The median nerve innervates skin and muscles on the lateral palm. It's going to help activate muscles to help you pronate the hand, flex the wrist and fingers, etc. The femoral nerve helps to innervate the quadriceps muscles. Excuse me. The sciatic nerve is the longest nerve in the body. It's the thickest nerve in the body as well. It helps to supply the entire leg. Now, some clinical applications. An epidural block. This is where you can inject medicine into the epidural space to help block from that point, that area, so you are not receiving the sensory information. You get a temporary loss of function. Now, usually you're going to lose both sensory and motor function to the spinal nerves in that adjacent area. The space is fairly narrow, so hopefully the person who's doing it knows what they're doing, because it can be kind of difficult. There is some risk involved. There's risk involved with just about everything, though. Oftentimes when a woman is in labor, if she wants to receive an epidural block, they will go between the L3 and the L4 vertebrae. Sciatica is when you have compression or injury on the sciatic nerve. Oftentimes the pain is felt all the way down the leg, even sometimes numbing to the toes. And this is something a lot of people do suffer from, especially if you spend a long time sitting where you have compression on that sciatic nerve. It's common one group of people that really seem to suffer a lot from it are truck drivers because they spend so much time sitting as they're driving. And one thing that they have found, I've known someone who suffered from this and was told that certainly in early stages it may not always work, but especially for men, oftentimes put their wallet in their back pocket and then sit and drive. That one thing that it gets you off center that way. So one thing that may help is if you're going to be sitting for a long period of time, do not keep your wallet. And nowadays, so many people, where do you put your cell phone? In your back pocket. Don't do that when you're sitting for long periods of time. Once again, whether you're driving or not, doesn't matter. If you're going to be sitting for long periods of time, don't have anything in your back pockets because it does get you a little bit off center. You may not even be fully aware of it, but your muscles start to make adjustments to that, and then that may put undue pressure upon the nerve, especially on the sciatic nerve.